Recording.
All right, guys, let's get started. All right, great. All right, let's get started. We'll go to content. You had your first assignment that was due on Sunday, so hopefully everyone submitted that. You have a second assignment that we started on Thursday, which is the substitution cipher. I will add the link soon. So we did the encryption function, and then you just have to do the decrypt function, the reverse of it. All right, and you will know that it works because you'll get the text. All right, so if you have questions, bring those up on Thursday. Today, I'm going to start going over XOR. So as I've hinted at before in previous lectures, XOR is one of the underlying procedures in cryptography, right? You can say like, you know, in calculus, you have derivatives, integrals, right? Or in linear algebra, you have matrix multiplications, or in geometry, you have sines, cosines, however you want to think about it, right? In cryptography, the underlying operation is XOR, given that operation is efficient because it's at the bit level and we want to be fast, right? So computers are basically logic gates, if you will, or states of, true or false, binary. And so those operations are done really quickly. All right, so we are going to now look at XOR this week. So XOR is used for several things: for integrity, for confidentiality. So today I'm just going to start with a basic example. We've done some Python code already with Python substitution ciphers. Now we're going to do Python code that will cover a lot of things, actually. So because for XOR, we need modes of operation, we need the XOR operation itself, we need block cipher. So all these ideas are going to come in. And then also, the first thing we're going to implement is probably the easiest one with XOR, which is actually hash functions. Okay, so we're going to do a hash. You're going to have a hash problem this week, right? And that's related to integrity. So there's like two goals this week. One is for me to cover kind of this XOR operation, and we're going to do some examples of that. And then the other one is to talk about the kind of the theory, right, in cryptography. So in this case, if the previous 2 weeks have been confidentiality, now this week we're going to start with integrity. All right, and if you remember, integrity is when someone hasn't tampered with, your message, right? So that's really what we care about. So we're going to think about how to create what is a hash, basically, and we're going to use also OpenSSL. So we're going to mix it up. OpenSSL is more powerful, so it's going to give us like SHA-256 and all that MD5 that you might be familiar with. But we're also going to implement a very simple algorithm leveraging the XOR operation to do a hash. And so you should be convinced that they're similar. Does that make sense? Okay, so that's basically the goal. So for this week, these two modules are where you should focus on. So Python XOR hash algorithm. This will likely be the homework for Thursday. So I may start with this, but I'm not going to get to all of it today. So I'll just go over the problem to kind of motivate, your goal, right? So you want to know where I'm going with all these things I'm going to tell you about. So basically the problem, there's only one problem in there. So complete the following problem as done in class. Number one, submit a report showing evidence that you completed the Python XOR hash cipher. So there's two things. I will just show you how to do the XOR. Then I'll show you a little bit about modes of operation, and that means breaking a message into blocks. But then there's the actual algorithm of hashing something. Okay, so we will, and I'll give you the algorithm that's part of the lecture today. All right, so you will implement this as discussed in class. You need to run it without errors and show evidence of calculating a hash. So you should understand basically that you were successful in implementing it. And then you're going to submit a report showing your work and results. So this will be, I don't like to create too many problems in homework assignments, so I keep them constrained as much as possible. But there are two aspects of this. So there's this one, which is pure coding, and then there will be another one, which is no coding using OpenSSL, leveraging OpenSSL. But I have two separate labs for this, even though they both relate to integrity. All right, so let's go over here to content. Again, so as I said, I've given you that one. We've talked about it. All right, so this is one module that should be on your radar. Also, I'll just kind of show you here. Sometimes I add slides and things or PDFs that are summarizations of the topics that we cover. So for instance, I have this PowerPoint slide, cryptography hash. So a lot of the concepts that I'll discuss today are actually in these slides. And so there might be some repetition, but one is more. I'll use the board today, and then you can reference this one later. So here you can see in this second module, I have crypto hash. So I also have a PDF of my notes. Then I have, again, PowerPoint slide of my notes. And then I have the problems basically that we will be looking at. So this is the OpenSSL part. This will be a separate assignment. It just depends on time, right? So I'm not exactly sure when I'll get to it, but they're both related to integrity. So you can see here, I have some problems. So again, I'll motivate what it is that you will have to do based on the lectures, right? So this I call the integrity hash algorithm. So integrity hash, kind of go together in this class. So complete the following problems that's done in class. So as usual, there will be a PDF of this, right? So that for you to read, okay, but you don't have to do the PDF. Remember, right? The PDF, there may be problems. There may be 20 problems in there. You don't have to do all of them. So I pick them and I change them, but I keep them consistent to what's in there. So problem number one, calculate hashes for a plain text file using MD5, SHA-1, and 256. So that's similar to what we've done in the past where we created a text file, you put in a little sentence or a paragraph, and then you would use OpenSSL to get these things, right? So we're going to discuss what they are as part of the lecture. Then problem two, you're going to calculate hash values using a key called an HMAC. So here you're going to repeat the process, but you're using a key basically for the hashing algorithms provided by OpenSSL. Once again, MD5, SHA-1, and SHA-256. Problem three, same question as we did last week. What happens when you corrupt one bit of the file, right? It's a corrupted file, create a file and hash it before and after corrupting one bit of the file. So imagine you have a whole movie, right? And you calculated a hash for it, and then you corrupt one bit of billions of bits. What's going to happen, right? What would you want? Has the integrity been affected if you just change one bit of the whole movie? That's the question, right? So we'll get to that. Then, as usual, you'll work with a partner. Now that you know how to calculate hash values with OpenSSL, craft an experiment where you could send a file to your classmate with the hash value. Your classmate should validate that the integrity of the file has been maintained. You can use email as usual. You must also encrypt the file before transmitting. This last step would provide confidentiality. So notice the question, and this is key. achieve confidentiality and integrity in one shot. Do you see what I'm saying? So this is how this class is going to get. I'm going to keep piling on principles and things like that. And I'll say things like, all right, now achieve authentication, confidentiality, and integrity all in one shot, right? So these are the things that you're going to want to understand as we move along. But I'll discuss this. So one email as a hint. Don't worry about securely sending the symmetric key for this lab. We've stated already from the previous 2 weeks that you still can't do that, not securely. There is no method like with what you know to do it. Does that make sense, guys? So these are the questions, 2 separate labs, 2 separate submissions, and this will be the second. The first one will be the XOR operation, which we will be using several times this semester. And so today is the first introduction to the code. But first, I will cover a little bit of the theory of hashes and integrity. Any questions before we begin the lecture? All right. So these are the documents for this week. Go back to table of contents here. Okay, so hash functions. All right, there we are. So I did play with the whiteboard, so this time it should work better, I think. So let's go. I'm going to switch to that. Green. Okay, so hopefully this will work better this time. All right. Yeah. So we're gonna start. So this is part of the lecture, the notes, and we're gonna go pretty far. I think it's an important lecture today. All right. So we are talking about Crypto Lab. This is the one-way hash. Guys, if you have any questions, let me know. So, the principle is integrity. So that's the first thing I'll mention. So the principle that we're covering is integrity. So it's the principle of information assurance. So if you remember at the beginning of the semester, these are the principles that we're covering. Okay. All right. So what is message integrity? Basically, you want to make sure that files have not been changed. All right. So they haven't been tampered with. Nothing has changed of them. So just add here. The goal basically is file has not been changed. Not been changed. This is the key concept. So you use this basically when you have, your movie, you download some software that you want to trust, right? That's really important, right? So this is how we know, when you, especially on Mac and things like that, when you download a file, you check the hash, corresponds to something that Apple has provided. The file has not been tampered with. You don't want to add something that means a virus or spyware or something like that. So that's the whole principle of hash numbers, right? And so today we're going to study the algorithms and some of the tools. So the basic approach is to provide a MAC, which is called a message authentication code. All right, so the basic terminology, something called a MAC, which stands for message authentication code. So now we're going to look at the scenario again using Alice and Bob. All right, so I'm going to go here. Alice needs to send a message to Bob. Okay, so say Alice. Okay, Alice will have can or cannot have a key. As we will see in the algorithm doesn't necessarily need to have a key, but you know, because it's a type of, but it's also a possibility. So Alice will then need to send the message to Bob. Okay, there you go. And then let's establish a key over here. So there's going to be a message, M, and the message will include a tag, basically. So there's going to be something called a tag or the code. And this can be something like 100 bits or so, right? So it depends on what you're doing, but think of it as a sequence of 100 bits, zeros and ones. That number has to be generated by something from the original message. Does that make sense? So keep in mind what's happening here. Alice is sending something to Bob. What is she sending? The message and the tag. So if I give you this scenario and I asked you true or false, just by this scenario, right? Is confidentiality being achieved in this task? What would you say? Why?
I mean, is the message?
You're right. That's the question to ask, right? So if the tag is calculated over the message, then they need to receive the message to recalculate the tag, right? So no confidentiality is achieved. Now you almost answer then, okay, how do I achieve both at the same time? Take the message, encrypt it, and then take the hash of the cipher. Do you see what I'm saying? So that's really important. So in this case, in this simple scenario, the only principle that's achieved is what? Integrity. Do you see how that works? Okay. So if I said, implement something that achieves only integrity, this is perfectly fine. Okay, so this procedure is perfectly fine. Any questions? So, when you send an email to your friend here, and actually you're told only achieve integrity, don't achieve confidentiality, for instance, for whatever reason, you would send a message and the tag. And they also need to know, okay, how did you obtain that tag given the message, right? And so that brings us to a function, the function that we need in this case, we're just going to call it S. Okay, we can denote it like this, S, and this function should return the tag. So we can rewrite this as, I'm going to go to a new page. All right, so now this is what we're talking about. There's the principle, and then there's going to be the algorithm that we can use for this task. So we're going to denote the function as, a tag, and that tag, you have a function. The function can take something like key or some vector, whatever you want to use. It can take M, okay? And basically that's the idea. All right, so that's something that someone would say, like, let's say NVIDIA's website or Apple's website, and they have, this is the tag. Download the file from here. When you download it, you check it, it should, unless they hacked your website, they can't change your tag, basically. Okay, so that's the key aspect. Any questions on that idea, guys? All right, so Alice will use a Mac message authentication code, or sometime, an algorithm, which is denoted by S in this example. And then Bob, on the other end, so Bob, needs to verify, right? And usually the verify algorithm is just an if statement that compares the tag received to taking the message, rerunning it through the algorithm, getting the tag, and it's like, okay, does it match? And so basically these functions just return yes or no, or true or false. Okay, that's basically what you need. So this is sometimes called the verification algorithm. So we're just going to say that Bob uses a verification algorithm. A verification algorithm. Okay. So this is going to be denoted. So we're going to say verify here. This is going to be denoted by the V function. Okay. And so this V function will take, in this case, since Alice used the S function to generate the tag and she used the key, then here you would also need the key. So it's going to be V K M and the tag that was received from Alice. And this function just returns either true or false. Okay. And that's basically the idea of this example. All right. So basically these two algorithms. So this is kind of the whole problem for this week, or the first problem, right? To create these two functions. So you're going to have to, just exactly as I wrote them, right? You need a sequence of bits. You're going to need the message. You're going to have to break it into blocks. You're going to XOR them in some scheme, and then you're going to produce the hash value. Okay. And then you're going to, that's it. There's only one way in these things. There's not like two ways. But the verify algorithm is like, it has the hashing algorithm inside and then an if statement, basically, that can print. Got it? That's what you have to do. So in this case, there is no encrypt decrypts, just like that. So so now we need to worry about this S function, right? That's where we're going to look at now. So we're going to start getting into the algorithm itself now that we understand the principles. All right, so we're going to look at this S function. All right, so the implementation basically. So Mac algorithms can be constructed from cryptographic primitives. All right, so you've heard me say that term since the beginning of the semester. Think of it as like Legos, right? So a cryptographic primitive could be the XOR operation, for instance. A cryptographic primitive could be block algorithms, right? Which is what we're going to understand right now, how to implement those block algorithms, take our data, and this is going to be specific to Python, basically. So there are things called hash functions. So you could build them like that. So let's say, so implementation. Implementation. So we have two options. We're only going to look at one option. You can look at this. These are the things that I leave for the end of the semester as projects. If there's a hash function or hash algorithm that you want to really go like really deep into, that can be your project. But it's got to be something, that has enough for you to do. Okay, so we can do hash functions like the actual crypto hash functions, that people create. Based on math, basically. Or we can do the block cipher algorithm, right? And that's the second option that we will drill down into this week. So block cipher algorithm. So these are the two options. And like I said, of these, switch colors here. Of these, we're going to do this one. We're going to focus on that. So now this is really important, okay? I'm going to give you a definition that is basically the definition of a hash function, okay? Like in words. So what is a hash function? Put it right here. And this might sound very simple at first, but it's really like important, all right? Very profound into what a hash function should be. So I'm going to write this down here. So a hash function. What is a hash function? So as we have established in this course, basically, we have a lot of functions that take an input and produce some output, right? That's the key, principle that we're using. And so a hash function is an algorithm that maps data of variable length to data of fixed length. Make sense? That's it. Okay, so don't forget that. The word mapping is really important, right? It's the underlying rules or algorithm or whatever it is. Okay, so then I'll repeat, a hash function is an algorithm that maps data of variable length to data of fixed length. So let's create a little circle here. Just going to say map, right? Those are the ideas. And then here we have input and output. So the input is variable length. That's really important because that can be, something long like a paragraph, right? It could be a paragraph, it could be a picture and a sequence of bits, something like that. But the output of that is always fixed given the algorithm, right? So we will see, for instance, for our example, you'll pick the block size. That's entirely up to you in Python how you do that. And then the easiest thing to do is to just use that block size as what? The length of the hash. Do you see what I'm saying? That's the simplest thing to implement. So you want 20 characters, right? In your block. Okay, that's basically then your hash value. That's the fixed length. The variable length would be, 3 pages of text, break it into blocks, hash it, and get 20. Got it? So that's really important. So here, I'm going to then say variable length. Variable length, text, text is represented as bits. So we always can think of it as bits. So in a computer, so variable length. That's what you get out. And then initially, I'm sorry. This should be fixed length. Sorry about that. This is fixed length. That's what you get as output. Okay, so fixed length and initially variable length. So what's nice about this definition is, regardless of what you do in the mapping, what your algorithm is, you always have a hash function as long as you go from variable length to fixed length. Okay, so that's going to be the idea. And hashes, I'm sure if you guys have taken other computer classes, they're actually used for other purposes, right? Like for referencing things and things like that. But here in this class, we're only using it for the purpose of integrity. Okay. All right. So that's it. It's as simple as that as far as the definition. of a hash function, our general hash function. Now we're going to drill even deeper into this idea by looking at a very simple hash function, okay, based on the XOR operation. So I will literally give you, this is what you have to implement, okay? This is what you have to implement in your homework assignment, this algorithm. I'll just mention it in a few bullets, and of course, I will show you as we start doing the code, you know, some of the examples. Make sense? So we'll go over that. Right, so let's go probably to a new page. We have enough room. Okay. All right, so let's call this very simple hash algorithm. Or hash function, sorry. Okay, so this is going to be our algorithm. All right, so a simple hash function. So practically speaking, all algorithms for computing in the hash code of a message view the message as a sequence of n-bit blocks. Okay, so that's the first assumption. So we're going to look at the message as a sequence of n-bit blocks. So step one, convert message M. Not sure what happened there. I convert message M. Somehow it became smoother. So it's nice. All right, so convert message M into a sequence of n-bit blocks. All right, so in a lot of the examples we're going to do for DES, AES, you know, modes of operations, etc., we always have to do this process. Okay, so we're going to learn how to do that. And if I, for some reason, skip that or forget to do it, remind me, because you're going to need it. Okay, so convert message M into a sequence of n-bit blocks. So n bits. We are gonna always want to, even though in the substitution example, we actually used characters and the ASCII table, here is probably better since we're really gonna use the XOR operation, like the actual XOR operation. So we're gonna have to take our strings, whatever they are, and convert them into byte arrays. And then once we have these byte arrays, you're gonna have to perform the XOR operation. So we're gonna think of it as n bits. Okay, or at least think of it as blocks of letters of a specific size. All right, so a sequence of n-bit blocks here. Of n-bit blocks. And as usual for the last one, you know, you may need to do some padding, etc. All right, the second step of the algorithm is now the message will be processed one block at a time in iterative fashion. The message is processed one block at a time in an iterative fashion to produce an n-bit hash code. Okay, you can see how this is giving you the idea. So now that we have a list of blocks, we're going to have to iterate through all these blocks, like in a for loop, right? And we're going to take each block and do what? XOR it, right? With something, so, or process it in this case. So the message is processed one block at a time. So I'm going to say process process one block at a time. So I'm going to put in, maybe here is a hint, you need to use a for loop, right? So for loop. Okay. Now, what's great about this framework, as I said, is it's going to be very consistent as far as we're using symmetric key encryption and so on. All right, so the message is processed one block at a time in an iterative fashion to produce an n-bit hash code. And perhaps the simplest hash function consists of starting with the first n-bit block, XORing it bit by bit with the second n-bit block, and XORing the result with the next n-bit block, and so on. So we're going to call this the XOR hash algorithm. Does that make sense? What you have to do? Okay, so I'll draw a picture of it, but let's just, and I'll give you a specific idea of this, but let's just give it a name. So this is going to be the XOR hash algorithm. Probably the easiest thing to do, hopefully, right? So XOR hash. Okay. So the XOR hash. Okay, so let's move to another page now and kind of do a diagram of how this would work. Okay, so we're going to take our message M, right? So that's our message M of a specific size. Dot, dot, dot. Right, so of some size. All right, then we're going to have to break this up into blocks. Okay, so I'm going to say a sequence of blocks or a list of blocks, which is what you can use in Python. Right, so now you're going to have a list. You can say 0, 1, 2, dot, 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 all the way to however many blocks you get, let's say n. So then in here, you're going to have, imagine these are blocks of specific size. And they're all the same size. N bits. Dot, dot. Do you see that, guys? So you convert basically your original message into a list of blocks of equal size, where the last one may need to be padded. Once you do that, what do? We are going to perform in a for loop, we're going to XOR these messages. So you can choose to create a block with random values right at the beginning, right, of the same size as the block, or you can create a key of the same size as the block, or just start XORing the blocks themselves. Okay, so that's entirely. So for instance, you would start one block 0. Remember that the XOR operation is denoted like that, right? And then you're going to do what? XOR 0 and 1. That's going to produce, and I'm going to say B to indicate block, okay? And then this would give us what? So let's call it hash 0. Do you guys see that? And then now, what are you going to do in the next step? In the next step, you can take, since we've done B1 to be consistent, you have to think about this, the logic of this. So this would be H0. And what are you going to do? You're going to XOR it with what? According to this logic, what do you XOR it with? B2, right? So you're gonna so if we XOR with this B1, this is gonna be B2. And what does that give you? It should give you each one. We know the blocks will be of equal size, right? So that's what I was saying. You've defined a block size, let's say 20 bits or whatever you want it to be, 128 bits, you know. It's that's entirely up to you. And then we just keep doing this dot until the last one, right? And the last one would be what? Would be H0. So it will be H n minus 1, probably. According to this logic, XORed by what? Bn, right? Bn. And that gives us what? Hn, right? Hn, and that's it. So at that point, that's your hash. So when you finish this algorithm, right, and you're gonna send something to your friend, who has to have this exact same algorithm to corroborate that the integrity has not been tampered with. What do you need to send them? You need to send them this message, and you're gonna send them that. That's your, yeah.
Would it be HN2?
No. So what I was doing, if you notice, H0 matches with this 0, H1 matches with this 1, so HN should match with this because I'm taking B1, B1, B2. That's a good point. It'd be B1, B2. Yeah, so maybe you're right. H0, H1.
I mean, like the input.
The input here?
Yeah, instead of n minus 1, it's n minus 2.
Yeah, so yeah, this is the tricky part of the algorithm, right? So let's see. I started with B0 and then H0, which is that one, right? Okay. That's, yeah, so this looked at that. Still think it's n minus 1.
Because of the for the third step that we did,
Yeah,
it would be H1 XOR block 3, which then get you hash 2.
let's do that. I think you're on to a good thing here. Let's do that next step, right? Let's see that. So I'm gonna do it in blue here. So H1, right? You agree? XOR. The block here would be B2, B1, so it'd be B3 here. The next one. Then this gives us H2, right? H2. Okay. So then HN. This means we would need an So this tells us by the logic of this algorithm, we need something like that, right? Which is actually, this is a good point to remind you that we've been using something called the initialization vector. That's what these things are for. Does that make sense, guys? It's a good catch. And what I will do, I'm going to implement this in Python, first of all, right? So don't worry about it. It's a good observation. The algorithm needs this either at the beginning or at the end. So because I did this like this is probably not the best way to implement it. I should have used an initialization vector, and this should have been 1, 2, 3. But yeah, good catch. By this logic, if I follow this, this is HN. since this is H2 and this is H3, this would actually need to be Hn plus 1, correct? Which doesn't exist. So we would have to have this as an initialization vector. And this, I still think this is n minus 1, right? Do you agree now? Because this is H1, this is H2. So if this is Hn, this should be Hn minus 1.
Yeah.
But this one is where we're having a problem, because that would need to be, see, if this is 2, so this is B n minus 1. This is H2, this is B3.
Yeah.
So if this is Hn, this needs to be Hn
Yeah.
plus 1. Do you see that now? Which means that doesn't exist unless we introduce that, which is the initialization vector. That actually explains what that IV was when we were doing the OpenSSL command. Got it, guys? It was a good observation. And like I said, I will implement this idea in code. And I think this was probably using these two, here, B0 and B1 is probably not the best idea. Instead, we should have an initialization vector so that it makes it easier and smoother. Got it? Questions? Does it make sense? So this is, in fact, the very simple hash function. And I'll repeat, practically all algorithms for computing the hash code of a message view the message as a sequence of n-bit blocks. So we've established that here, right? Created from the message the sequence of n-bit blocks, so all are of the same size, n bits. The message is processed one block at a time in an iterative fashion to produce an n-bit hash code. We did that here. That's our hash. Perhaps the simplest hash function consists of starting with the first n-bit block, XORing it bit by bit with the, see, that's why I did that. So XORing it bit by bit with the second n-bit block, XORing the result with the next n-bit, and so on. And we can call this the XOR hash function. So I'll modify it a little bit by moving the initialization vector to the beginning. Any questions? Now, one nice thing about this, as I said, this same logic will help you when you do data encryption standard or a mode of operation or something like that. We'll get into that. Okay. All right. So now, basically, what do we need? We need to start looking at the XOR operation and so on. Right. So we're going to switch over to our virtual machine. Yeah, so hash functions and integrity is probably one of the simplest concepts this semester in cryptography. Okay, if I ask you in the exam, what is a hash function, etc., what is integrity, how do you accomplish it? This is the key slide, right? So a variable length mapped to a fixed length. Okay, we've established that in the algorithm. And you should convince yourself that this meets that condition. Why? What is variable length? M, right? That could have been, you notice, in fact, I just did ... That implies it could be of any length. So variable length, what is the fixed length? This one over here, right? The block, n bits. Okay. All right. So hopefully that made sense. All right. That as far as the lecture slides. Now let's go ahead and switch over to the virtual machine, and we're just going to try to start. We're going to start coding this up. I don't know that we'll finish today, but we can continue on Thursday. And then remember, your homework assignment will be to fully, if I go back to Brightspace, we completed this one, we completed that one, Python XOR hash algorithm. You have the definition of it in a lot of detail. And you will have to submit a report showing evidence that you completed the Python XOR hash cipher as discussed in class. You need to run it without errors and show evidence of calculating a hash value, like print out something, right? Questions? All right, so this is what we're about to work on. I'm gonna go back to Zoom here. I don't need the whiteboard anymore. So... I'm just gonna do. Oh, up here, sorry. There we go. All right, I closed the whiteboard. So now I'm gonna share.
You go to
Hmm?
so you can go to screens.
Screens.
Yeah.
I
You go to
need
share.
I need to exit this. So I clicked on that.
Yeah, you go to share.
Where
At
is
the
share?
bottom.
The bottom?
Yeah, the middle bottom.
Mm-hmm.
If you click on that one, you go to screens at the top. If you go
Oh, okay, yeah. Perfect. Thank you. Yeah, all right, cool. All right, so yeah, we're back. So now let's go ahead and start the virtual machine VM. And we're going to start writing this in Python. Okay. So I have to give you some operations, some examples of how XOR should work. And then we're just going to slowly start to build this up. It's not a very long piece of code, but you know, we want to take our time with it. And later on, we're going to start adding things to it. You may need to have a padding function. Keep that in mind. If you want to generate an initialization vector or a key, is basically the same function. So we need to have something like that, gen key or gen IV. The only difference there would be that one you keep a secret and the other one you don't. You see that? So it's essentially the operation can be the same, but the secrecy is different. Then we need a function probably to get this list sequence of blocks. So we might call it get blocks. Then we're going to have a function generate hash or something like that. Okay. Later on, this same code can be expanded to confidentiality, and then we're going to have encrypt and decrypt, like you said. And then I'll add some other things like reading from a file, etc., as we're going to need that in the future. All right. Now within that, we're going to need to have the XOR operation. So we'll play with that idea as well. I think it's starting. Yeah. All right. Here we are. So we should have this already. I'm going to share it again. All right. So we have about 40 minutes. So I'll try to advance as much as I can. And then on Thursday, we should work on finishing the assignment. Okay. So what's that one? So somebody, I've had students in the past. I'm going to do some examples and And we did the math, right? We did the examples on the board where I did zeros and ones and we XORed them. So they actually wanted to do that. They like converted, got the string, manually converted letters and things to zeros and ones, and then they wanted to perform the operation. That's intuitively what they were trying to do. That's not what we're going to do, right? So instead, we're going to use a function called byte array in Python. So you won't actually see exactly that operation. So I want to make that clear because I've seen that happen in the past. Students just like start implementing the way that you do it by hand. Okay, so, you know, make a note of that. You can, but it's just a lot of extra work. All right, so we've got the screen here. So I'm going to go ahead and open a terminal, as usual. All right, here we are. So shell cd into desktop. Here. Shell. And I'm just going to continue using my folder ITS 350 fall 2024. Clear. All right, I'm going to create a new folder here, and I'm going to call it XOR hash. Hash. Again, if you're having issues finding where you are, type pwd. Find, make sure you're in the right place. Now, so I'm going to do ls. I'm going to cd into that folder, XOR hash. Hit clear. All right. So this is where we're going to start creating our script. Initially, my message is going to be hard coded into the code, and then later on we have to start learning how to read and write the files. This is going to become very important in this class, as you're going to be dealing with lots of things like, you know, secret key, public key, private key, initially set, you know, lots of parameters, right? So we need to be able to store those effectively and store them in as byte files, right? So bin files, not as text files, binary files. All right, so the first thing is I'm going to run Python 3, as you guys can see. The version of Python I'm using is 3.9. Okay. So the symbol for XOR in Python is that. This is called the caret in the keyboard, and that's what we can use for XORing. Okay, so the XOR operation in Python is that one. So let's see if that works. If I do 0, 0, 0. You guys see that? If I do 1, caret 0, 1. You guys see that? So that's basically like if I did 2 + 2 is 4. Here I'm doing a binary operation because that's the underlying operation that we do between byte arrays in our encryption. And so I wanted to show that to you. We will be using this operator. Okay, I'll do all 4. Here I'm using the interpreter, which I believe I had shown to you before. You're not going to code in here, but this is just handy. Why does this work? These are not necessarily, you know, we're not going to be writing binary like that, but you can see that this does work. So 0, caret 0, I did 1, caret 0, it should be 1. Now I'm going to do 0, caret 1, that's also 1. And if I do 1, caret 1, oh, sorry, no, 1, caret 1, that should be 0, correct? Yeah. All right. Very good. So we've proven that that's the operator for binary operations. All right. Now, the other thing that we're going to try to do is to use a function called the byte array. Okay, and this is the function that's going to create from some input, whatever it is, our sequences of bits that we will then proceed to XOR and so on. All right, I will exit out of here. I just wanted to show you that operator. And then I'm going to start creating a script. I'm just going to say nano XOR hash function maybe .py. Okay, so it's just simple script, and we're going to proceed to write our code in here for our problem. Okay. So same idea as before. I'm gonna write in here XOR hash. We're gonna need a message. So I'll start at the kind of the message here. You can make this message as long as you want. So my message or plain text message, whatever you want to call it. Double quotes here. So this can be a string. This is a secret message. Okay, so that's going to be our initial message. As I said, I'm going to make this longer just so that I can test this out. I will also start with just blocks of size 8. So they're going to be 8-bit blocks just to, you know, start, but you can always increment that to 16, 32, whatever you want as you know, make your code more robust. All right, I'm going to do a print here. So print my message. That, so we can go ahead and run it. So I'm going to use Python here. And there it is. This is a top secret message. Okay. So now let's create a function. So let's go ahead and just create several things. So it's like I'm going to create a few primitives, if you will. And then from there, we can start building. So let's try a function, gen key, my gen key. And keep in mind, this could be the exact same code for your function, my gen IV, for instance. So the initialization vector that we're going to need. In fact. But let's just do something like this. Now, what do you need here probably? What's important about these things is the length, the dimensions, right? So we want to establish, so in my case, I want to do like 8 bits to start with, something small maybe, or something like that. So then, once I have this function here, 1, 2, 3, 4, I'm going to just return a byte array. So Python has a function called byte array, which can be used for that. So, okay. So it should be byte array. Okay. And then I'm going to specify that it's a byte array. It's like typecasting. If you're familiar with typecasting, like going from string to int or int to string, it's a similar concept. Now within here, I'm just going to create a random sequence. So I'm going to say urandom. And remember, I've already said things about randomness, right? In this course, maybe in other classes, that's as far as you go. Here we have to say a little bit about random. These are in fact pseudo-random algorithms, right? So not secure. So it should be random like that. And then what we need to provide most likely in here is the length. Okay, length of, and that's it. So this is the function. Hopefully that should give us a key, just keep it secret, or an initialization vector. What matters is that it should be of the same size, right? So that, because otherwise the XOR operation will not work, right? It needs to be blocks of equal size. So now let's try it. So we're gonna test it out. All right, so we're gonna try out the function. So I'm gonna go down here. And I'm just gonna say key in this, my key or key in this example. And the function was my gen key. Right, like that. Okay. Now, urandom is a function that we need to import. So I'm going to say from OS, which is the operating system module for Python, import urandom. Okay, that's that function I'm using down here. It's just a built-in system function. Yeah, and then I'm just going to say 8. Let's go with that. Yeah, right here. Let's say length. Okay. And let's go with 8. Let's see what happens, right? So we're going to go with that. So then here I'm going to plug in length. And then we're going to print out key. All right, let's see if this works. All right, so I'll come back to the code if it works. So now I'm going to, okay. What did we print? The actual key, right? So yeah, there it is. Does that make sense, guys? Any questions? Nope. All right, a key, very important thing that is a little bit like, it's gonna maybe cost you problems when you're coding this, is this term here. See that there's a little b there? That means, a binary array, okay? You kind of will have to use this sometimes, okay? You'll have to, like, when you're like reading things or writing things, you want Python to know, okay, this is not the string \x b8. This is the hex representation of that. As you probably can tell, these are hex values, right? Hexadecimals. So it's not showing you binary. It's showing you like the other numbering system, right? Hexadecimal that you've learned before. Any questions? Pretty easy, right? Okay. All right. So we can go back. So we've seen it now. And now we can proceed to continue, all right, with our code. All right. So we will basically XOR using that, right? That's the first initialization vector or whatever it is. But we need something else, right, to XOR with this. So we need some message. All right, so then we need to start creating either the sequence of blocks or something like that, right? So we need to start thinking about that logic, how we're going to accomplish that one. Right. So get the blocks. Let's see. All right, so let's start creating a function called get blocks. And then we're gonna start building this up a little bit. So let's think about this. It's going to need plain. What is plain? That's the message, right? Variable length message. It's going to come into this function. We're going to need to split it up into the blocks. Okay, and then we need to know probably the length somehow. Okay, which we have 1, 2, 3, 4. All right, so we have that. So I'm going to, if you remember when we were discussing the algorithm and I said a sequence of blocks, I just said list the blocks. So I'm going to create a list of blocks. In Python, Python can handle list of any data type. So these could be byte arrays if we wanted to, or whatever it is. So that's going to work fine for us. Okay, so we're going to have a list of blocks. And okay, so let's try. We've done something like this before, so hopefully this should be consistent with the substitution example. Because what I'm getting in plain is a string. This is a top secret, which will make this longer a little bit later. But that's the same thing that we did in substitution, right? In the substitution example, I had a string and I just kind of went through some of the letters. So this builds up a little bit on that logic. And, by the way, there's many ways of doing this. This is just like the way that I've chosen to do this, but you guys could come up with creative ways. So 4-letter in plain, right? 1, 2, 3, 4. 1, 2, 3, 4. All right, so I have my letter, and we can start debugging it if we want, but I'm just going to say block equal block plus letter. Obviously, I'm going to need to define this term block. It is just a string right now. Block. And it's just an empty string. Okay. So what I'm going to do, my suggestion right now, my logic is basically I'm going to grab 8 letters, create a block. Then I'm going to grab the next 8 letters, create a block, and so on. Do you see that? And I will need to worry about padding because otherwise this algorithm will break since you're building everything from scratch. Okay. So let's go ahead here. So you can make some decisions like, do you want to pad before you send plain into here, or do you want to do the padding here? It's up to you, right? So we'll have to decide that. But I have a block now. So 4-letter in plain, we're gonna need to have some kind of a counter. It's like the easiest thing I can think of. So I equal I. Oh, sorry, I0, right? So we're gonna initialize it to 0. We increment it here. I equal I plus 1, right? Pretty straightforward. And then after that, you need to say if length of block, if length of block equal length, right? 8 or 15 or whatever it is, then that's a block, right? And then you need to continue to the next block and so on. So if it's that, 1, 2, 3, 4. So now if it meets that condition, list of blocks dot append. And what do you append to this list of blocks? Block. Got it? Does that make sense, guys? All right, so that's basically it. Pretty easy. All right, so now that I have that, once a block is appended, you need to say that the block is equal to nothing again, or empty string, because you're going to be preparing for the next block. Also, the counter is going to be incremented or reset to 0. I equals 0, just like that. And then 1, 2, 3, 4, you're going to return list of all right, that's it. This would work, except for the fact that the last block may need padding. Do you see that? So it might break there. So let's actually do that. So let's print block every time. And then we'll need to solve that problem, basically. So right. So let's go ahead and so the function is get blocks, and we need to provide 2 parameters. So now I'm going to go here. I'm going to say my list of blocks. So my list of blocks is going to be get blocks. And this takes my message, right? My message, and it takes length. Now let's take a look at this. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that should be the first block. 1, 2, 3, 4, 5, 6, 7, 8. That's the second block. 1, 2, 3, 4, 5, 6, 7, 8. That's the third block, fourth block. And then 1, 2, 3, 4. So I think we're short 4 bits in this one, right? So I would need a padding of 4. So since you want this to work for any message, we're going to need a padding function. Obviously, if I just added 4 spaces here, it would probably also work. But let's run it like this. Yeah, so, okay. Control X, Y. Here. Plus. And it did not error out. Okay, that's good. So this is 1 block. This should be the second block. This one has a space in it. This is the third block, and I guess it didn't do the 4th one. Do you guys see that? So you got to solve that problem. But this is, we're kind of getting there. Now we have a key, which is this one, right? Should be 8 bits. We have this, should be 8 bits. Now we can XOR. Got it? Any questions? Yeah, please.
Can you go back to the coding?
Yeah, of course. So hopefully it's starting to make sense. And remember that with these primitives, these mechanisms, you have to build an XORing, a hash XOR model architecture. Any question? Yes, please. Where? Do you have a what does it say? What does yours say?
It says 4.
400. Okay, I'll take a look in a sec. Did some of you get this though? Did some of you get this? Okay, great. All right, so let me missing the for letter and name. Open the script. So for loops have
Mine's invisible.
probably the colon also. Open the script. At the end, so after if statements, yeah, for loops, functions, I'll bring up the code in a sec. There should be a colon, okay? Did you open it? Yeah. Function colon, no colon. Oh. So,
Somebody pop.
just give me a second. Yeah. What's your error? Colon. Everyone's the same error. Yeah, open up the script. It was an if, I see at the end of the if, there should be a colon, just like after the for. What was yours?
I would have got. I would have fixed it, but would it be invisible and stuff there, or would it be?
You may not open your script. Maybe your print is empty. Because it's trying to print, but go to the where the print. Yeah, if your print is empty, you have to put block in there. All right, guys, so I saw the same question. I saw the same error in most of you. So Python is excellent, except for two things. It's very unforgiving about indentation. So, and you guys have used C, C++, or Java script or something like that, and you use curly brackets, right? And then indentation didn't matter. But because Python is supposed to be readable, it doesn't use curly brackets and things like that. But instead, you have to be very precise about indentation. That's why you see me always going 1, 2, 3, 4, and don't mix tabs and indentation. The other thing is this colon. I saw a lot of you were missing this one. So the colon needs to go at the end of the define function. It's like it's saying a block is starting, okay? So you have to put a colon there, or if you use an if statement, you put a colon, or if you use a for loop, you put a colon. Does that make sense? So just make a note of those two items, and hopefully that should work for you. Any other questions? Is it making sense what we're doing? Okay, so this logic, as I said, one nice thing about this is it's very consistent, right? So what we're doing, we will use for confidentiality as well. We'll use XOR as well. So these are just basic building blocks. All right, so for some reason, I did not get an error, which I expected I would get an error. I guess what happened was the last block was not of size 8, right? So it was not added. You see what happened? The last block was not of size 8. I believe it was maybe of size 4. So it's not in the list, but my code did not break. So you have a problem there because you need to act for integrity, right? You need to actually go over the whole message. That's the whole point of it. And calculate the hash based on the whole message. When you do the confidentiality, what if you say attack at, and you're missing dawn, and then you're like, probably the evening. We always attack in the evening, and then everyone gets killed, right? So you got to also do the whole message, right? So that means we have to do padding, all right? That's the other function that needs to happen. You had a problem about that in the last 2 weeks that you needed to resolve. So we need to think about what padding is going to be like. I think, honestly, I like functions that are very short. So let's just instead create a new function that will take the message first, take a look at it, and if it doesn't meet the condition, it's a multiple or something of the size of the block, then we pad it, right? So that's kind of what we want to. So we have about 10 minutes. So let's start doing this function today, and then this will be where we pick up or after this on Thursday. And then you guys will need to finish this algorithm on Thursday. All right, so let's go ahead here. So the function would need to go here, right? Because I want to give the function get blocks a message that has already been padded. Okay, so I'm going to say my message like that, and it's going to go through a function, and this function we can call, you can call it my padding or just padding. And my message needs to go in here. Message needs to go in there, just like that. Right? So now we need to proceed to pad it. So I'm just going to add a function here. Yep, just like that. So again, define padding, open parentheses, close parentheses. Don't forget the colon here, right? And this takes the message. We probably want to send a link. Then I'm going to have to pass that here. Length. Okay. So the whole point of this is that it should check that the file can be divided into blocks of that size exactly. And if not, to pad it with spaces or something like that at the end for that many values that are missing. Remember, if you change, I'll try to make this code in such a way that if you change length, it'll work, but just keep that in mind, right? So I'm only trying this out right now for a length of 8. As you start getting your algorithms to be bigger, you know, you'll need to modify. So when we do RSA and things like that, we're going to try larger blocks and larger keys, right? So to see the performance hit of, you know, because that's another thing, right? So you might, you know, the longer the key, the more secure you might assume, but also then the more processing that has to happen, which means that the algorithm becomes slower, which means once again, like if you're downloading your Netflix movie, it'll take 30 minutes for the whole thing to download before you can start watching it. So you have to always be mindful of performance when you're working with cryptographic algorithms. Okay, so yeah, padding. So let's go ahead to the padding function. All right, so we started it here. It's got the length and the message. 1, 2, 3, 4. Okay. All right, so what do we need? Yeah, let's start with the simple thing. Let's debug it actually. So I'm going to do print. I want to know the length of this. This is just for debugging purposes. I want to know the len of length. Oh, actually of message. Sorry. The length of message. Yeah. All right, so I'm going to print this out. I'll run it. Give me an error. Get blocks. Try that again. What broke? If you guys see the error, let me know. Something broke in here.
I'm pretty much getting the exact.
Huh?
I'm getting the exact same.
Yeah, you're getting an error. Do you guys see what broke? And well, I have a statement though. I have print, so it's not because of that. So this good observation. Why did it break? Because all I did is I added this, my message My message, let me take this out. That's on. All right, so it's back to normal. So the error is there. I called padding. I give it message, which is a string. It shouldn't be because this is the local name, it's the local variable for this function. And the other one is in that scope. So it shouldn't be that. Where do I have my message? See, I got this my message here, which goes in here. And it just changes it to this one. It works when you change it. You mean this one, my message one? That's really odd. Yeah. Maybe I'm missing something, but I feel like that's not a Python problem. All right, let's go with this solution for now. So then this is my message one here. Okay, so let's keep trying it. So we're looking at padding. Okay, we got 2 minutes, so let me just real quick. Nope. For letter and oh, I think I know what it is. It actually is what she said, is the return. The function, it's being assigned to the function. I knew this was a weird error. Okay, so I think I know what it is. So I'm gonna go in, I'll close with this. I believe this can stay. That's my message like that. This one can stay at that. But I am assigning my message here from the function. And I didn't do a return, which, yeah, that was bad of me. So if I do return here, and I just return hello, for instance, do you see that? Then it's now going to get hello, a string, and not a non-type object, which is the error I was getting. So that makes more sense. Yeah, so it was somewhere there was a non-type object. Yeah, so there was a non-type object going on in there, and that was because the function was not returning. So what was a string was becoming non. Do you see that? Yeah. All right. Okay. It's 5:39. So you guys know where we're at. I'm basically working on this padding. So I'll just write something like here we are, we're here. And then we will just pick up at this exact point on Thursday to kind of finish up this algorithm. Hopefully you'll get a lot of the primitives, a lot of the tools that you need to start getting into these techniques. Okay. All right, guys. So we'll stop here for today, and I'll see you on Thursday.
Thank you.